Let's solve a projectile motion problem involving a launch from a cliff. A projectile is launched from a 50-meter cliff at 30 meters per second at 40 degrees above horizontal. We need to find where it lands. First, we need to break the initial velocity into horizontal and vertical components. The initial velocity is 30 meters per second at an angle of 40 degrees. The horizontal component is 30 times cosine of 40 degrees. That gives us 22.98 meters per second in the horizontal direction. The vertical component is 30 times sine of 40 degrees. That gives us 19.29 meters per second in the vertical direction. Here we see the velocity vector broken into its horizontal and vertical components. Next, we need to find how long the projectile is in the air. We use the vertical position equation, y equals y0 plus v0y times t minus 1/2 gt squared. The initial height is 50 meters, and final height is 0 at ground level. Substituting our values, 0 equals 50 plus 19.2, 9t minus 1/2 times 9.8 times t squared. Simplifying, 0 equals 50 plus 19.2 9t minus 4.9t squared. Rearranging, 4.9t squared minus 19.2 9t minus 50 equals 0. We'll solve this using the quadratic formula. The quadratic formula is t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Our coefficients are a equals 4.9, b equals negative 19.29, and c equals negative 50. Substituting into the formula. Calculating. 19.29 plus or minus the square root of 372.10 plus 980 all over 9.8. That's 19.29 plus or minus the square root of 1352.10 over 9.8. The square root of 1352.10 is 36.77. Taking the positive solution, t equals 56.06 over 9.8, which equals 5.72 seconds. Now we can find the horizontal distance traveled. The horizontal distance is simply the horizontal velocity times time. That's 22.98 meters per second times 5.72 seconds, which gives us 131.4 meters. Here's the complete trajectory, showing the projectile landing 131.4 meters from the cliff base. Let's verify our answer makes physical sense. The projectile is in the air for 5.72 seconds. The horizontal velocity remains constant at 22.98 meters per second throughout. It started 50 meters high with an upward velocity component. So a horizontal distance of 131.4 meters makes perfect sense. Our final answer, the projectile lands 131.4 meters from the base of the cliff. Let's summarize our solution. The horizontal velocity component is 22.98 meters per second. The vertical velocity component is 19.29 meters per second. The total time of flight is 5.72 seconds. The projectile lands 131.4 meters from the cliff base.